In this video, I'm going to explain the meaning of the p-value and how we use it to interpret results from a hypothesis test. Let's suppose we have this left tail test hypothesis. So let's suppose mean is less than 15. So this is how you set it up. And mean equals 15. The null hypothesis should have the equal sign, and the alternative will always have less than, greater than, or different from. Let's suppose we have the sample mean 14.2, the sample size is 24, standard deviation is 2.3, and the claim, let's say the claim is, we're making a claim that the mean is less than 15. Okay, we want to test this claim at the 5% level of significance. The 5% means it is the maximum allowable probability of rejecting the null hypothesis when we should not reject it, means when it is true. So you're making a mistake of rejecting the null hypothesis when it is true. So the probability here, the maximum allowed probability is 5%. So let me explain what the p-value here is. So first of all, let's calculate the test statistic. This is the second step. It's x bar minus the mean divided by s over square root of n. X bar is 14.2 minus the mean. You get it from the null hypothesis. We assume that the null hypothesis is true until proven otherwise. 2.3 is the standard deviation divided by square root of 24. If you do the math, you're going to get negative 1.704. Let me show you what the p-value is. So this is the normal, the t distribution. It's a t here. When the population standard deviation is not given, and which is the case in most problems, we have what we call a t distribution. So I'm going to put t here. Okay, this is the mean right here. Okay, what is this value? So this is 0 in the middle. Negative 1.704, it will be, let me put it on the number line, negative 1.704. Now let me show you what the p-value is. Okay, I'm going to draw a line here. I'm going to shade the area to the left of this test statistic. The p-value by definition is the probability of observing a value that is extreme or as extreme as the value obtained from the sample. The value that we obtained from the sample was 14.2, which is the sample mean. We changed that to a standardized test statistic. It turned out to be negative 1.704. So the p-value is the probability of obtaining a value that is as extreme or more extreme than negative 1.704. Now the question you will ask, why did we shade to the left, not to the right? Because it's a left tail test. So the extreme is going to go to the left in this case. So this is this area that I shaded, it's called the p-value. Now how do we use the p-value? First of all, to find the p-value. To find that p-value here, you run a t-test. You input x bar, you input the value 15 first in the null hypothesis. You input x bar, you input s, n. And then you choose the alternative test, which is less than, and then you hit calculate. This is going to give you the p-value. The p-value, I just ran the test, and I like you to double check on that. Turned out to be, with 4 digits, 0.509. How do we use the p-value? You compare the p-value with the level of significance alpha. If the p-value is more than alpha, you fail to reject HO. If the p-value is less than alpha, you reject HO. Well, here I have 0.0509, which is very close to being a 5%, but it's slightly bigger, so it's greater than what alpha, and our decision will be fail to reject HO. Now what about if we have a right tail test? Let me show you how that works with the right tail test. So I'm going to do another example with the right tail test. HO, let's say mean is 15, H1 mean is greater than 15, and this is the claim, and let's say N again is 24, let's say X bar is 16.2, let's say S is I don't know, 2.5, I'm just making up stuff, and let's say alpha is again 5%. So what we're going to do, we're going to calculate the test statistic T, which is X bar minus mean divided by S over square root of N, which is 16.2 minus 15 over 2.5, and everything over what? Square root of 24. Let me see what the answer is here. T is 2.352. Double check on that to make sure that you know how to perform the calculations in here. Let me show you what the p-value is here. Let's do the curve. So I'm going to put the T, which is, this is 0 here, this is the T line, and the 2.352, you agree it's going to be to the right of 0. Okay, now I'm going to shade to the right of this one. Why am I shading to the right? Because I have a right tail test. And this shaded area, guys, is what we call the p-value. The p-value is the probability of obtaining sample statistics as extreme or more extreme than the one that we obtained from the sample. More extreme here goes to the right because we are doing a right tail test. And the p-value here turns out to be, I think I have the answer, 0.0138. Well, this is less than alpha, which is the 5%. So what's the decision here? We reject HO. So I hope that will help clarify what the p-value is. You can use technology, and in order to find the p-value and the test statistic here, you will have to use what we call a t-test. My next video is going to be about critical values. So this is what the p-value is about. You can use technology. So p-value is an area under the curve, and alpha is an area. So we compare two areas, p-value with alpha. Always. Alpha will always be given in the problem.